Okay, as we start and finish up Chapter 7 with Topic 8, Complex Numbers. Now again, I'm hoping that you've had the class, but just in case, we'll do a little quick review. Now, there are a number of different kinds of numbers. We have, for instance, natural numbers, which is 1, 2, 3, 4. We have whole numbers, which are 0, 1, 2, 3, 4, and so on. Then we have the opposites of those, which give us the integers, which is the negative whole numbers in a sense. And then we have fractions that come between this, and these are the rational numbers. And rational is often a synonym for fractions. And then there's irrational numbers too that we have in there, like the square root of 2 and others. And then all of these are on the number line, our traditional number line, and these are real numbers. So all of these are real numbers on the number line. But then we get to a case where we have something like number 5. As we look at number 5, it's the negative 49. And there are no real numbers that will actually make this. So in the past, whenever we had something like this, we would say, there's no real number solution for this. But then we can move up to numbers that are not on the number line. And the mathematicians in the past sort of invented this. They said that suppose we let the square root of negative 1 be defined as the letter I, such that if you squared both of these, remember by taking the radical sign away from this, the square root then of, or if you squared negative 1, that would just be its radicand, and that would be I squared would equal a negative 1. So they sort of set that up in the background, and since it wasn't a real number, they had to give it a name, and in the past they gave it the name an imaginary number. Now it's actually not imaginary. It is, we can't use the word real, but it's a true thing. It's just not on the number line. So what we need to do for all of these is to define what is I in the sense, and we define it as the square root of negative 1. So what we do when we have an example like this, we take out, in a sense, the square root of negative 1 times the square root of 49. And the square root of negative 1 we said is I. So this is going to become 7I. The I being the square root of negative 1, and 49, the square root of 49 is 7. So we can just write these now as taking out the square root of negative 1 times the square root of 17. This is I, the square root of 17. And again, this is going to be the square root of negative 1, which is I. So in a sense, this is I, the square root of 200. And in a previous lesson, we said that can be simplified into The square root of 100 times the square root of 2. So the square root of 100 was 10. So this is going to be 10I, the square root of 2. Now the I is the square root of -1 that we write as I. Now here we have a negative, and it's going to be similar to what we have up here. So this is going to be negative 7I because of the negative outside. Inside here, this comes out as 7I. Now we apply that negative 7I. So here we have 8. Now that's going to be a minus. Now here, you recall this was the square root of -1. That takes out the I. Then it was the square root of 25 times the square root of 6. So square root of 25 is 5. 5I, the square root of 6. Now, let me mention something here that you'll see from time to time, is that sometimes they put the letter I at the back instead of there. And that's perfectly okay. The I would come there. The problem is that if you're not careful when you make the radical sign, someone may think the radical sign extends over the letter I if you put it there. So by putting it there, makes it neater and doesn't get confused. Okay, for this one, we notice we have the square root of, let me take away that negative sign there, -1. Then you have the square root of 32, which is the square root of 16, times the square root of 2 for this one. And this is going to be a negative, and this is going to be the square root of -1, the square root of 9. So I'm trying to give you, again, a strategy of how we got to different places. We just know that this is an I and this is an I. So over here we have 4I, the square root of 2, minus 3I. Now, the answer they give in the book is they factor out the I. I don't know why they did that, but this is good like this. And if, well, let's show you that way. If you just factor out the I, you would have 4, the square root of 2, minus 3, and then the I out there. Well, I don't know. All right, now we've gone from converting to now adding where the I is present. Now the interesting thing about the I is that it's treated just like a variable. So it's like 3x, 3I. All of the rules apply. So here there's addition. 9 plus 3 is 12. 5I minus 2I is a positive 3I. Now another thing comes into play here as well, and I better be sure I give it to you, and that is when we write things that have I in it, these are complex numbers. And complex numbers are above real numbers. So on the number line we have real numbers, but if we add these imaginary numbers to it, they make a group called complex numbers. And complex numbers, when they're written, must be written in the form of A plus BI, where A is a real number and I is an imaginary number. So the combination of the two make it a complex number. So we have written this number in standard form. Okay? And that's what we'll continue to do. Again, they might have had that in your class. We're just reviewing it here. So here we have 5 and 11. That's going to be 16. A negative 7i and a positive 4i give you a negative 3i. Okay. Now notice number 13 is subtraction. And what we do when we subtract is we take away the parenthesis and just change these signs. So now we have a 3 minus 6 is a negative 3. A negative 8i and a positive 2i makes that a negative 6i. Same thing here. Take away the parenthesis and just change the signs. So this is going to be negative, this will be positive, and now we just add like terms. A negative 2 and a negative 9 is a negative 11. A negative 5i and a positive 7i is a positive 2i. And notice these are all in standard form. Now I probably should have waited to the next sequence, but I put number 15 up there. And you might say, how is 15 different from the others? Well, here we're asked to multiply. And again, the rules are just the same, except for one little thing that I'll tell you about in a moment. So 8 times 11 is 88. I times I now is I squared. Okay, now if you leave it like that, even though it's technically correct, they're going to count it wrong. Why? Well, because we defined in the beginning that I squared is a negative 1. So whenever you come across I squared in a calculation, you must make it a negative 1. So 88 times a negative 1 is a negative 88. And that is the answer. Now notice what went on here. You had an imaginary number and an imaginary number. You got a product, but then it became a real number. Ah, wow. We made this imaginary number into a real number. And this is the beauty of math. Okay, going on to some more examples. Now, an interesting thing happens. If you multiply, take the square root of this and get 10, square root of this and you get 9, and they're both negative, you think you would end up with a positive. But when you're dealing with complex numbers, you can't do it this way. So the way to do this is this becomes 10i, and this becomes 9i, and you're going to multiply them. So this becomes 90i squared. And what is I squared? I squared is negative 1. So this becomes a negative 90. Now notice if you just multiplied the radicans, it would have made it a positive. But you can't do that. You have to do it this way. It's going to become a negative 90. So here we're just distributing. This is going to be a, let's see, 10i minus 8i squared. Now if you left it like that, that would be wrong in two ways. First of all, it's not in standard form. And you never leave an I squared in an answer. So remember, I squared is a -1. So the opposite of a -8 is a +8. And there is your answer. Notice it's in standard form. So here we're going to get a -18i plus 3i squared. But what is I squared? I squared is a -1. So this becomes a -3 minus 18i. Okay? And that's the thing to remember. As you do these, they're going to come out like this. You're going to have to change the sign of this and put it in standard form. Now, as we look at number 19, here we're multiplying a binomial by a binomial. And again, the same techniques of what we did before. In fact, I may have put too many i's in there. Yeah, there's no I there. Sorry about that. Okay. I got I crazy there. All right, so we're going to FOIL it. We'll use the old technique. Do my first. This is going to be a -10. Now I'm going to do my outers. That's going to be a -12i. My inners, a +15i. And my last, a +18i squared. Now I could have done it mentally, but it's always good to kind of review and check it out. So now we combine like terms. This will be a -10. This is going to be a +3i for my middle term. That checks. And a +18i squared. But what is I squared? I squared is a -1. So this is actually a -18 here. We have like terms. A -28 plus 3i. Okay. All right, let's FOIL this one. Let's do this one mentally. So this is going to be 21. This is going to be a -28i and a -9i. I believe that's going to be a -37i. So 28 plus 9 is 37. And when we multiply our last term, we get a +12i squared. But we know that I squared is a -1. So this is a -12. A -12 and a 21 become a 9 minus 37i. Okay. Now for 22, and again in our next chapter, chapter 8, you're going to be using this technique, so it's something you need to learn as we do the special product of squaring a binomial. Square the first term. Multiply these two terms together. That gives you a -28. Double it. That's a -56i. Square the last term. That's a +49i squared. But we know that I squared is a negative 1. So this is a negative 49 and a positive 16. That's going to give you a negative 33 and a negative 56i. It's in standard form, and all our answers have to be in standard form. I don't know if I mentioned that I like working with complex numbers. This is sort of one of my favorite areas. Okay, again, we want to practice squaring a binomial. So we square our first term. That gives us 100. We multiply these two terms together and then double it. So that's 30. Doubling it is 60i. And we square our last term. That gives us a positive 9i squared. But we know that I squared is a negative 1. This is a negative 9. So our standard form, up over there and over here, is going to be 91 plus 60i. Okay, so this was multiplication. Now we're going to do some division, and it looks a little strange. It looks like fractions, but we want to sort of like rationalize our denominators here a little bit. And keeping in mind we're going to eventually put things into standard form. And we go into our mathematical toolbox, and what we end up with is this word right here, conjugate. Conjugate is something that when you multiply, nice things happen. So for instance, in this one, and let me write it again here because I ran out of room. When we have a division of fractions in which there is an imaginary number in the denominator, we want to get that out of there. And to do so, we multiply it by its conjugate. That is, the denominator by its conjugate. So what is the conjugate of this? And your teacher may have said that it's the same terms, but the opposite sign. So it'll be 2 minus I. And to keep it equivalent, we have to multiply the numerator by 2 minus I. Remember, 2 minus I over 2 minus I is 1, and we're allowed to multiply anything by 1. But an interesting thing happens when we FOIL conjugates. Remember, the old thing was A plus B, A minus B. This became A squared minus B squared. The middle terms canceled out. Oh, because that's what we want. So this is just going to become 4 minus I squared. So 2 times 2 is 4. A negative times a positive is a negative I squared. But what did we say I squared was? I squared is negative 1. So the opposite of a negative 1 is 5. So our denominator here is going to become a 5. And now we just distribute. This gives us a 6 minus 3i. Wow. Now suppose you put that in the math lab. They'd count it wrong. Why? That's the answer. We've rationalized the denominator in a sense. Because it's not in standard form. Well, what do I have to do to put it in standard form? Well, the only thing you have to do is to write our denominator over each of the terms. So now the answer is, and you can put that negative sign right over there, 6/5 minus 3i fifths. I guess I can move that over a little bit too. Now that is in standard form. Okay? So let's go on to number 24. Again, there's an imaginary number in the denominator. So here we're going to modify the conjugate just a little bit, and instead of multiplying it by a big number, we're going to use a small number. We're just going to say multiply it by a negative I. So this numerator now becomes negative 11i, and our denominator becomes 5, a negative I squared. But what did we say I squared was? I squared is a negative 1. So a negative 1 times a negative 5 makes my denominator a positive 5. And for number 24, that should be the answer. And that is the answer. Okay. So here, the same thing. We're going to multiply it by a negative I, and this by a negative I. So, our denominator, this becomes a negative 2i squared, but I squared is a negative 1, so our denominator now becomes a positive 2. So this is a negative I squared, which is a negative 1, times 2. Let me just be sure I'm doing that correctly. Yes, I was good on that. So again, if we just write it out, and I perhaps should write these out a little bit more, 2i times a negative I is a negative 2i squared. And I squared is a negative 1. A negative 1 times a negative 2 makes it a positive 2. And that's what I had. Now, when I distributed this, I got a negative 6i and a positive 5i squared. But that's not in standard form, and we can't leave that positive I squared there. I squared is a negative 1, so this is going to become a negative 5. Now, is that in standard form? No. So we have to put it a negative 5 over 2. And notice here we can actually do some canceling out. So this is going to be a negative 3i. Or if you want to keep it that way, let's see, how does the book do that? No, they put it this way, yeah. So that's how it is. Yeah, when you put it negative 5 over 2 minus 6i over 2, this cancels out and you get a 3, and that's what we have. Okay. Again, we are showing you strategy here, but we also want to be sure you understand what we're doing. So the conjugate of this now will be 5 plus 3i. So again, this is a 1, but it's nice that we're going to get rid of our imaginary numbers in our denominator. So this becomes 25, and this becomes a negative 9i squared. But we said I squared was a negative 1, so this becomes a positive 9. So our denominator is 34. Now as we FOIL the top here, 3 times 5 is 15. Let's see, our outers are a 9 and a 10. So this looks like a 19i. And our last term is a positive 6i squared. But we know that I squared is a negative 1, so this becomes a 6, a negative 6. So this will be then 9 plus 19i over 34. And you might say, oh, that's our answer. But it would be counted wrong because it's not in standard form. So we have to remember that we just write these over separate fractions. And instead of having that I completely up in the numerator like that, they have it over here, which is, for all practical purposes, the same. Okay, lots of stuff going on here. And you're getting ready for your test, I know, too, so hopefully you're going to do well in that. Now, as we wind up Chapter 7, these radical numbers and then adding to it complex numbers, we get to an interesting part. I always like this part, where we are to simplify powers of I. And to do this, we're going to build up a little something here, a little background, that we know that I equals I. And remember, I is the square root of 1. And we know that I squared is equal to negative 1. Well, as we go to I to the third, this is I squared times I. Well, we know that I squared is negative 1 times I. So I to the third is negative I. And then I to the fourth, you can think of it as I squared times I squared, which is negative 1 times negative 1, which is a positive 1. Now as we go to the next level, I to the 5th, 6th, 7th, and 8th, remember that we can think of this as I to the 4th times I to the 4th times I squared, I to the 4th times I to the 3rd, and then I to the 4th times I to the 4th. So in a sense, all of these I to the 4ths are 1. So when you get to I to the 5th, in a sense, that just equals I, because I to the 4th is 1. And then I to the 6th is I to the 4th, I to the 2nd. This is 1, this is a negative 1, so negative 1. And so on and so forth. It makes a pattern that every time you get to the 4th power of something, it's going to be a 1, 4th power of I. So that may have to sink in a little bit, but basically that's it. So if we went to the next level, where this would be I to the 9th, I to the 10th, I to the 11th, I to the 12th, the answers would be the same, because this would be I to the 8th times I, and this would just be I, negative 1, negative I, 1. And notice, I to the 4th is 1, I to the 8th is 1, I to the 12th is 1. So any fourth power, in a sense, as they are multiples of each other, are just going to be 1. So as we look at number 27 here, let's see if we can do something here. This is going to be I to the 4th raised to the 11th power. Now what is I to the 4th? I to the 4th is 1. 1 raised to the 11th power is 1. All right, now this is a negative I to the 10th power. So if we were to write this out, we would write out 10 of these parentheses with a negative in it. And we said anytime a negative is raised to an even power, like 10, it becomes a positive. So in a sense, you can convert this to I to the 10th. I to the 10th is I to the 8th times I to the 2nd. I to the 2nd is a negative 1. And that's our answer to number 28. Okay, this one is 2 to the 3rd. That's 8. And then, let's do it this way. 2 to the 3rd times I to the 3rd. I to the 3rd we said was negative I. Back over here. Well, 2 to the 3rd is 8. 8 times negative I is negative 8I. And then here, 2 to the 5th is 32. I to the 5th is I to the 4th times I to the 1st. I to the 4th is 1. I to the 1st is I. So number 30 is 32I. Now you're going to have to try this, and hopefully you're catching on how it works. And that's the presentation. I guess you're getting ready for your test, and good luck on that.